Welcome to Global Trends. Please subscribe and hit the bell icon for more breaking updates. The universe is a vast and complex place, and for centuries we've built tools to help us understand it: telescopes, microscopes, and most recently, computers. Classical computers, the ones in your phone and on your desk, have mapped genomes, predicted weather, and sent spacecraft to the edge of the solar system. They speak a simple language of ones and zeros, a binary code that's built our modern world. But at its core, the universe doesn't speak in simple yes or no answers. It speaks in probabilities, in maybes, in strange connections that defy logic. To understand this deeper reality, we needed a new kind of tool, the quantum computer. This isn't just a faster version of what you know. It's a machine born from the bizarre rules of quantum mechanics, where things can be in multiple places at once and linked across vast distances. Building one is among the greatest scientific challenges of our time. Imagine a massive maze. A classical computer tries every path one by one, but a quantum computer explores them all at once. This leap in computational power lets us tackle problems that are impossible for even the most powerful supercomputers. Problems in medicine, materials science, and the very nature of reality. We stand at the edge of a new frontier. The development of quantum computers is as significant as the invention of the telescope or the microprocessor. It's a fundamental shift in how we process information and how we understand the cosmos. We're moving from counting on our fingers to grasping the infinite. The journey is just beginning, but these new machines are already starting to whisper the secrets of the universe. We just have to learn how to listen. The symphony of quantum states could rewrite everything we thought we knew. The adventure is underway. The universe is inviting us to think in new ways. In late 2024, Google researchers announced a breakthrough, a processor with 2048 qubits. Just a few years ago, experiments struggled with a few dozen qubits. Scaling up to thousands is a monumental leap. So what did Google do with this machine? They simulated a complex quantum system, a digital universe inside the processor. This was a test of quantum mechanics on a scale never before possible. The goal to see if our world behaves as theory predicts when many quantum particles interact. This was a test of the universe's operating system. The result? Quantum supremacy on a grand scale, a calculation no classical supercomputer could match in a human lifetime. Google's machine performed a task that would take the world's fastest supercomputer thousands of years. But it wasn't just about speed, it was about proving that quantum computation works as theory suggests. The simulation mostly matched quantum theory, but there was a tiny, persistent anomaly, a subtle deviation from the expected outcome. It couldn't be explained by noise or error. It was as if the simulation had brushed up against something unexpected, a whisper in the data, a ghost in the machine. This anomaly has the scientific community buzzing. It suggests we may have stumbled upon something profound. The quantum age has its Kitty Hawk moment. To understand Google's discovery, let's look inside the computer. Classical computers use bits, on or off, 1 or 0. Billions of these switches power everything you do online. But a bit can only be in one state at a time. Enter the quantum world. Quantum computers use qubits. A qubit is like a dimmer switch that's also spinning. Thanks to superposition, it can be a 1, a 0, or both at once. It exists in a cloud of probabilities, collapsing to a definite state only when measured. This lets quantum computers process many possibilities simultaneously. With a few hundred qubits, you can represent more states than atoms in the universe. Then there's entanglement, Einstein's spooky action at a distance. Entangled qubits are linked measure one, and you instantly know the state of the other, no matter how far apart. This interconnectedness is a key resource for quantum computation. So while a classical computer is like reading one book at a time, a quantum computer reads every book in the library at once, seeing how all the stories connect. It processes information as a vast evolving wave of possibilities. This is what lets quantum computers tackle immense complexity. They don't just calculate, they simulate reality at its most fundamental probabilistic level. And in this simulation we found a hint of something more. The fabric of reality may be stranger than we ever imagined. What is this secret layer that Google's test may have revealed? Imagine playing a video game. You know its rules, but you don't see the code running beneath. The anomaly in Google's experiment suggests our universe might work the same way. Our laws of physics could be the game physics of our reality, emerging from a deeper, hidden code. The test may have created a condition so extreme it caused a glitch, a tiny interaction with the universe's underlying code. This secret layer wouldn't be made of matter or energy as we know them, but something else entirely. Think of a shadow puppet. You can study the shadow, but you'll never understand it fully without knowing about the hand casting it. The anomaly could be the first time we've seen the shadow of our universe flicker, hinting at the hand behind it. This isn't about living in a simulation like in the movies, it's more profound. The fabric of space-time and the laws of physics might not be the final reality. They could be emergent properties of a deeper, more complex system. Google's test may have given us our first experimental clue that this deeper level exists. If this discovery holds up, it could revolutionize science. For decades, physicists have searched for a theory of everything, a framework uniting general relativity and quantum mechanics. This secret layer could be the missing link, the source code from which both theories emerge. By studying quantum anomalies, we might reverse engineer the universe's fundamental rules. This could unlock the mysteries of dark matter, dark energy, black holes, and even the origins of the universe. It would open a new field of physics exploring the substrate of reality itself. Chemistry, material science, and medicine could be transformed. Imagine room-temperature superconductors or cures for diseases by understanding quantum processes in the brain. Even our concepts of time and causality could be up for review. Questions once left to philosophers could soon be tested in the lab. This isn't just new answers, it's a whole new set of questions. A secret layer of reality might sound abstract, but history shows fundamental discoveries always shape our daily lives. The electron gave us electronics, relativity powers your GPS, quantum mechanics is behind lasers and MRI machines. The practical applications of this new knowledge could be even more transformative. Imagine manufacturing at the atomic level, creating materials with unimaginable strength and lightness. Medicine could be revolutionized, diagnostics at the single molecule level, therapies that repair DNA with perfect accuracy. Communication and security could be redefined with truly instantaneous, unhackable methods. Our digital infrastructure could be rebuilt on a fundamentally more secure foundation. The world would become more connected, efficient, and secure. With great power comes great responsibility. Ethical implications will require global conversation, but the potential for good is immense. New energy sources, solutions to climate change, and a more equitable future. This is about building a better world for all humanity. We are explorers by nature, driven to understand our place in the cosmos. Quantum computers are the next great tool in this adventure. Google's 2048 Qubit test is our first glimpse of a new continent of knowledge. The path ahead is challenging, but the rewards are boundless. We're on the verge of a scientific revolution that could reshape our world and our understanding of ourselves. The universe is always more intricate and surprising than we imagine. This journey isn't just for scientists, it's for all of us. Insights from these machines will inspire new art, philosophies, and technologies. They'll help us solve the great challenges of our time. This is a story of human ingenuity and our relentless quest for knowledge. As we stand on the shore of this new quantum reality, let's look forward with wonder and optimism. The universe has revealed a new clue about its deepest secrets. The possibilities are, quite literally, universal.